Okay, let's get started. All right, so we're going to pick up from exactly where we left off yesterday. I don't have any announcements other than to make sure to at least get started on the homework that's going to be due next Monday. And remember that we have an exam next Friday on the 23rd. And so make sure to go ahead and start reviewing for that. I'm going to write a review for it, but you can always go back and look at my slides and the old homework to start reviewing for that. Okay, so do we have any questions about anything before we get started? Okay, so like I said, today we're going to pick up from where we left off. So we're talking about increasing and decreasing functions today still, and the first derivative test. We're going to cover the first derivative test today. Okay, so as a review of increasing and decreasing functions, a certain function f of x defined for all real numbers has the derivative f prime of x equals x times 2x minus 1 squared times x plus 4 cubed. Use this to determine on what intervals f of x is increasing or decreasing. Has the answer key posted? I thought I did. I thought I posted the answer key. I will check after this to see. All right, so we want to check and see on what intervals is is f increasing or decreasing. So how do I do that? How can I tell if f is increasing? Here we don't even have f. I only have f prime of x. So how can I tell where f is increasing given f prime? What do we think? Do I need to take the derivative of this and set that equal to 0? Or is my tone telling you that there's a trick to this problem? This is a prime exam problem, by the way, just so everybody knows. So the intervals on which f is increasing and decreasing depends on f prime, right? So first step is to find the critical numbers. So how do I find the critical numbers here?
Take the derivative.
I would take the derivative of f, right?
Mm-hmm.
And that's already done, actually. I have f prime. So what do I do with that? In this problem, I'm given f prime. Yeah,
Set
thank you. What were you going to say?
Set them equal to 0, right?
Yeah, I'm going to set this equal to 0, right? So I need to solve x times 2x minus 1 squared times x plus 4 to the third equals 0. So I already gave this to you factored. And so when I set this equal to 0, well, either x is 0, right, from just setting that first factor equal to 0, or this factor equals 0. And what does x equal if this factor equals 0? 1/2. Very good. Thank you, Saba. Or this equals 0. And what does x equal if x plus 4 cubed equals 0? If x plus 4 cubed equals 0, then what does x equal? Yes, thank you in the chat. X equals -4. Excellent. So we did step 1 right there. Reminder that we didn't differentiate f because we already have f prime. And in fact, we don't have f at all, but we actually don't need f at all to be able to say where f is increasing and decreasing if we have f prime. Okay. So then step 2 was to make a table, right? I'm going to make a big table. This is defined on all real numbers. So I'm going to make a big table, minus infinity on the left, and then I'm going to list my critical numbers in order. So minus infinity, -4, 0, 1/2, and then positive infinity. Okay.
Okay, so I have a question real quick, and it's
Yeah.
probably really dumb, but how did we get 1/2 out of that? Because if you divide 0 by 2, it should just be 0.
But yeah, excellent question. So when you first do, if you do 2x minus 1 squared equals 0, well, when I take the square root, the square is just going to go away. And then you have to add 1. Well, you don't have to do anything, but you can. I would add 1 to both sides first here. I would do 2x equals 1. And then divide by 2, then x is equal to 1/2. If you divide both sides by 2 first, that's also fine, but you need to be careful. If you divide both sides by 2 first, multiply by 1/2 times 1/2. I agree that this right-hand side is still 0, but you would have to distribute the 1/2 to both the 2x and the -1. And you would get x minus 1/2 is equal to 0. And
Okay,
so,
that makes sense. Thank you.
of course. Okay, there we go. So I make a table of values. So I'm going to have, then I'm going to list my factors on the left, x, 2x minus 1 squared, and then x plus 4 cubed, and then f prime is the product of all of those things. Okay, so okay, so now I just need to determine the sign. Really, I only need to determine the sign of f prime, but determining the sign of all of these things is going to help me in doing that. Okay, so what sign does, let's start with this row here. What sign does x have when x is between minus infinity and -4? Well, what test value could we plug in?
-5.
-5. Excellent. And when we plug in x equals -5, what sign does that have?
Minus.
Yeah, minus. Cool. And what sign does, I guess we'll do the first column. What sign does 2x minus 1 squared have? Hint, it's something squared.
Positive?
It's positive. In fact, this whole row, we don't need to do any work to get this whole row. Anything squared, I'm going to get positive all the way across. Okay. So that's nice. All right, and then what sign does x plus 4 cubed have when x is -5?
Minus.
Minus, very good. So then f prime here between minus infinity and -4, well, that's going to be positive times, or sorry, negative times positive times a negative is going to give me a positive. Okay, and so f is, I'm going to try and give myself a little bit more room here. F is increasing between minus infinity and minus 4. Okay. So what test value should we take between minus 4 and 0?
-1.
X equals -1. Very good. All right. What sign does X have when X is -1?
Minus.
Minus. Very good. What sign? We already filled this one out, so that's a plus. And what sign does X plus 4 cubed have when X is -1? Well, I'm going to get -1 plus 4 is 3, and then I'm going to cube it. So that's going to be positive. Yes, positive. There we go. So F prime here is going to be a negative times a positive is going to give me a negative. Okay, so F is decreasing. This is really what F looks like. F is decreasing between -4 and 0. What test number should we plug in between 0 and 1/2? Yes, thank you, Sawa. We could plug in X equals 1/4, right? Fractions. So what sign does X have between, or sorry, at X equals 1/4? At X equals plus 1/4, what sign does X have? Yeah, it's positive. Very good. All right, and then we already filled out the second row. And so for the third row, what do we get? When X is positive 1/4, yes, thank you, Saba, it's going to be positive. So between 0 and 1/2, we've got a positive times a positive times a positive is going to give me a positive. And so F is going to be increasing there. Okay. All right, last row, or last column, what X value do you want to use?
1.
X equals 1, perfect. So what sign does X equals 1 have when X is 1? Yeah, it's positive. Very good. And what about X plus 4 cubed? What sign does that have when X is 1?
Positive.
Positive. Very good. So in this column, we also get positive times positive times positive is positive. So never assume that a function goes from, if you have a critical number, that F changes from going from increasing to decreasing or decreasing to increasing there. You always have to make this table, okay? Because there could be some sort of trick happening. So F is increasing between or really between minus infinity and -4. F increasing between minus infinity and -4. Where else?
Union 0 to infinity.
Union 0 to, and this is where some authors would maybe argue with you. I would normally just write 0 to infinity, yes. But at X equals 1/2, F prime is 0. F prime is not positive. So what we're going to write is union 0 to 1/2, and then union 1/2 to infinity, okay? This does have the advantage of, if you tell someone F is increasing on these intervals, they can see clearly, because there's this weird break at X equals 1/2, they can see clearly that there's a critical number at x equals 1/2, so that f prime is 0 there. Okay. So, and then f is decreasing. Well, it's decreasing between -4 and 0, right? Okay. So, do we have any questions? Could we see it in Desmos? Well, I can show you the derivative in Desmos, but the actual function, we're going to learn about this later, actually. The actual function, there are infinitely many things it can be. If I give you the derivative, there are infinitely many things it can be. If you gave me a few minutes, I could work out one possibility for f, but this function is 3, 5, 6 degree polynomial, so I would need a minute to work it out. But you can plot just the derivative to see that we found the correct intervals of increase and decrease. And then why do we have a critical number at x equals 1/2? Well, again, that's from you set each of these things equal to 0. So a critical number doesn't mean, this is a good segue, a critical number doesn't necessarily mean that you have to have a relative maximum or relative minimum. Sometimes with functions, particularly think of y equals x cubed. With y equals x cubed, if I take a derivative, I get y prime is equal to 3x squared. And so that has a critical number at x equals 0, right? But when I plot y equals x cubed, I'll just use Desmos. When I plot y equals x cubed, oh, oops, sorry. Y equals x cubed, there we go. Come on. Oh, y cubed. X cubed, there we go. When I plot y equals x cubed, we see that it has a horizontal tangent at the origin, but that's just where the function sort of flattens out. And so the function itself is going from increasing, and then it has a critical number. So it has a horizontal tangent line there, but then it continues to be increasing, okay? So critical numbers don't have to be where a function has a minimum or a maximum. Critical numbers also correspond to something like this, where the function just flattens out for a second and then continues to increase. Okay, so any other questions? That's a good question. And the first derivative test is going to tell us all about if we're in this situation, or something where the function just flattens out and continues to increase, or flattens out and continues to decrease. These are kind of the 4 options we have for functions of a single real variable. All right, so that brings us to the first derivative test, okay? So the first derivative test says the following. So we're going to let f of x be a continuous function in some interval that we're calling I, and c is a critical number of f in that interval I. Okay. If f is differentiable in some open interval containing c, then if f prime of x is greater than 0 in an open interval AC. So this is just, we need some real number where f prime of x is bigger than 0 between A and C. And then f prime of x is less than 0 in an open interval C to B for some A and B, then f of C, well, this says, so if I make a little chart, that means f prime we're looking here at A and C and B. A is between C and B. So F prime is going from positive to negative. And so that means F is going from increasing to decreasing, right? So F of X has to have a relative maximum at C. So F of C is a relative maximum. Okay. I will shorten relative with rel most of the time. Okay. So if the opposite situation holds, then so if F prime of X is less than 0 in an open interval A to C, and F prime of X is greater than 0 in an open interval C to B for some A and B, well, then F of C is going to be a relative minimum. This is where F goes from decreasing to increasing. Okay. And then lastly, if F prime of X does not change signs at C, then F of C is neither a relative maximum nor a relative minimum, okay? So my advice to you is don't memorize all of this at all. don't memorize this at all. Memorize what we've done before with the table. Because with the table, again, if you draw what F is doing underneath the table, you can see exactly what F has to do at the critical numbers, okay? So are there any questions about the first derivative test? Okay. So a proof for a relative maximum. So what does it mean for F of C? We want to show that F of C is bigger than or equal to F of X for X in some interval A to B, okay? Where here A is this A, where F prime is bigger than 0 between A and C, and B is this B, where F prime of X is smaller than 0 for X between C and B, okay? So how are we going to show that? Well, we're going to say that we know that F prime of X is bigger than 0 for X in A to C, right? And F prime of X is smaller than 0 for X in C. That already looks like a C. C to B, right? So F of C minus F of X over, let's say for a second, oops, let's say X is less than C for a second. Then F of C minus F of X over C minus X. What is this equal to? What does this look like?
Mean value theorem.
Yeah, this looks like the right-hand side. I'll put it on the right. this looks like the right-hand side of the mean value theorem, right? The mean value theorem, once you learn it, you can use it to prove so many things, okay? So this is the right-hand side of the mean value theorem. So this is equal to f prime of, I'm going to say, y for some y between x and c. Okay. And then I'm also going to assume x is less than c, but I'm going to assume that x is in this interval a to c. Okay. So that means y is between a and c. Okay. First statement at top contradicts the third statement. The first statement at the top contradicts the third statement. No, I don't think it does. Gotcha. Yeah. The first statement's for the function. The third is for the derivative. Yeah. But definitely keep me in check. If you guys have any questions, let me know. And if you think I'm messing something up, definitely say something. Okay. So y is between a and c. So that means that's exactly where f prime of c or f prime of x is bigger than 0, right? That means f prime of y is bigger than 0. Okay. So this is bigger than 0. We're assuming x is less than c, so c minus x is bigger than 0. So that means f of c minus f of x, that is bigger than 0, right? Or in other words, f of c is bigger than f of x, which is exactly what we wanted to show, at least halfway. Okay. But that really illustrates the whole idea of the proof. To save time, I'm going to say that we're basically done. The other thing you would want to do then from there is say, take x, let's say c is less than x, and then you do the same thing again, but then f prime of c, f prime of x there is smaller than 0. You do the whole thing again, and you'll also find there that f of c has to be bigger than f of x. Okay, and so this means f of c is a relative maximum because there's an interval on which f of c is bigger than f of x for all x close to it. Okay. Any questions on that? The key to the proof is the mean value theorem, okay? All right. So we're going to find and classify all the relative extrema for the function f of x is 1/5 times x to the 4th minus 4x to the 3rd. Okay. So I'm finding relative extreme values. So with the first derivative test, that's exactly what the first derivative test helps us to find, right? So I'm going to need, obviously, the first derivative. So apply the first derivative test to a bunch of critical numbers. Okay. So how do I find the critical numbers of this function?
Take the derivative.
Take the derivative. Very good. F prime of x equals, well, the 1/5 is going to come along for the ride, 1/5 times. Then I'm going to take the derivative of x to the 4th. What's the derivative of x to the 4th?
4x cubed.
4x cubed. Excellent. And then minus the derivative of 4x cubed.
12 minus 12x squared.
12x squared. Excellent. All right, that's the derivative. I'm going to factor it because we're going to set it equal to 0. So each of these has a 4x squared in common, right? So I'm going to get 1/5 times 4x squared. When I factor 4x squared out of here, I'm just going to be left with x. When I factor 4x squared out of here, I'm just going to be left with minus 3. Okay. So then what are the critical numbers of this function?
Zero and 3.
0 and 3, excellent. Because you just set this, let me give myself a little more room here. You just set this equal to 0, right? So yeah, exactly. I'm going to get x equals 0 from this factor, and then x equals 3 from this factor.
Excuse me, I have a question.
Yeah.
When there's like a constant, so that 1/5, does
Mhm.
that, and like since it can't equal 0, does it just like we do just not like look at it?
Yeah,
count it or
excellent
whatever?
question. Yeah, that's exactly right. So the idea behind factoring is if I have a product of 2 or more things and I get 0 from it, then I know at least one of those things had to be 0, right? But 1/5 is clearly not 0. So yeah, you're exactly right. I mean, you could set 1/5 equal to 0, but you don't get any solutions from that, right? So yeah, that's why we ignore that when we're doing this factoring and setting equal to 0. Any other questions? All right, so then we have two critical numbers that are going to break up our number line. We're going to go from minus infinity to 0 to 3 to infinity. And then our function our derivative is factored as 4x squared. I'll put the 4/5 on this guy times x minus 3 and then f prime. Okay, so what sign does 4x squared over 5 have between minus infinity and 0? Well, we should pick a test value, right? So what test value should we have? -1. Very good. So what sign does 4x squared have, or sorry, 4x squared over 5 have? Yeah. Yeah, very good. Thank you, Saba. And so it's a squared thing times 4/5. So we're going to have positives all the way across this row, right? Does that make sense to everybody? Because it's x squared, so we want positives all the way across there. Okay. So what sign does x minus 3 have when x is -1?
Negative.
Negative. Perfect. So what sign does f prime have when x is -1?
Negative.
Negative. Perfect. Because positive times a negative gives me a negative. So f is decreasing between minus infinity and 0. Okay. What sign does x minus 3 have between 0 and 3? Well, you should pick a test value. So what should my test value be?
One.
1. Perfect. So when I plug in 1 into x minus 3, what sign does that have?
Negative.
Negative. Perfect. And so f prime of x between 0 and 3, what sign does that have?
Negative.
Yeah, so I'm going to get positive times a negative is going to give me a negative. All right, and then lastly, what number should I pick here as a test value?
X equals 4.
Equals 4. Perfect. All right, and so what sign does 4 minus 3 have? Yes, thank you, Saba. It's going to be positive. 4 minus 3 is 1. That's a positive number. So f prime, what sign does f prime have? Oh, I forgot to draw what f is doing here. So f is also decreasing between 0 and 3. Sorry. All right, and what sign does f prime have between 3 and infinity?
Positive.
Yeah, you're going to get positive times a positive is going to give you a positive. So f is, this is what f is doing. F is increasing between 3 and infinity. So what relative maximum or minimum values do we have and where?
We have a relative minimum at 3.
Perfect. Relative minimum at x equals 3. And then the only other place we could have a relative extreme value is at x equals 0, right? But f of x goes from decreasing to decreasing there. So there's no relative. So f of x does something like this. It levels out and then decreases again. Then it has to bottom out and then start increasing. So there's no relative maximum and a relative minimum at x equals 3. Okay. Yes, at the bottom, this is a very, very, very rough sketch of the shape of the original function f of x. Okay. So that means we do need to find, if I ask you to find all relative extrema, I didn't ask only where do they occur. So I wanted to know f of 3, which is equal to, well, I'm going to get 1/5 times 3 to the 4th minus 4 times 3 cubed. Well, that's 1/5 times 81 minus 4 times 27, which is 1/5 times, well, 4 times 27 is what, 108? 81 minus 108. And that's what, negative 27? 108 minus, yeah. So negative 27 over 5 is relative minimum. Okay. So again, I found f of 3 because we not only do we want to know where the relative minimum occurs, but we want to know what the relative minimum is. Okay. So if I plot this function in Desmos to see what is happening with this function, well, Desmos, this function is 1 divided by 5 times x to the 4th, x to the 4th minus 4 times x to the 3rd. Oops. Okay, and so there's the graph of that function. And there's the relative minimum value at 3 minus 5 over 4, or minus 5.4 rather. Okay. And notice that there's no relative maximums occurring here. This function's increasing, or this function's always bigger than that negative 5.4. Okay. So, are there any questions about this?
So because you're asking for like the relative extrema, we don't write how f is decreasing, like the unions, and we don't say how it's increasing.
Excellent question. No, yeah, if I'm only asking you to find and classify all relative extrema, you technically have to do that along the way, but you don't. Yeah, you shouldn't explicitly give the intervals on which f of x is increasing or decreasing.
Okay.
Yeah, I only want, you do find that when you make this table, but I really only want to know what are the relative extreme values. Excellent question. So your answer for this one would be minus 27 over 5 is a relative minimum. And it occurs, you could also say it occurs at x equals 3. Any other questions? All right. Okay, so let's do this problem here. Find and classify all the relative extrema for the function f of x is x to the fourth plus 1 over x. Okay, so I need to find, if I'm finding relative extrema, your first step is always going to be find the derivative, right? So how can I find the derivative of this function, x to the fourth plus 1 over x?
Quotient rule.
I could use the quotient rule, yes. I'm going to, don't forget that if you simplify this though, this is really the same thing as x to the third plus 1 over x, which is x to the minus 1, right? So if we simplify this, then we can actually use a simpler power rule, right? But if you want to use the quotient rule, that's fine. You should get the same thing that we're about to get. So if I differentiate this, then what am I going to get from the derivative of x cubed? The derivative of x to the third is what?
3x squared.
3x squared. Perfect. And then what's the derivative of x to the minus 1?
Negative x to the minus 2.
Perfect. Minus x to the minus 2. Again, that's just all we did there was the power rule. Okay.
Excuse me.
Yeah.
Can you explain how you got like x cubed from like how you rearranged f
Oh,
of
yeah,
x?
yeah. Definitely. So I'm adding two things over one denominator, right? So the idea is I can break this up into x to the fourth over x plus 1 over x, right? Normally we go the other way. Normally we get a common denominator and then write it this way. But if we sort of undo that, if we write these both as over the same denominator, then, well, x to the fourth over x is x cubed, and then 1 over x, that's the same thing as x to the minus 1. Was that helpful, or did that just make it more confusing?
Yes, thank you.
Okay, good. All right, so I want to set f prime of x equal to 0, right? So this is the same thing as 3x squared minus 1 over x squared. We'll get this back over a common denominator. So this is 3, to get a common denominator, I'm going to multiply this by x squared over x squared, right? So I'm going to get 3x to the 4th over x squared minus 1 over x squared. Well, that's just equal to 3x to the 4th minus 1 over x squared. Okay, so if this is equal to 0, then what do we know? If a fraction is equal to 0, then what has to be true?
The top is equal to 0.
Exactly, the top is equal to 0. So I want to solve this guy. So we get 3x to the 4th minus 1 is equal to 0. Well, that tells me I can add 1, divide by 3, I get x. Oh, well, I'll add 1. 3x to the 4th equals 1. So that means x to the 4th equals 1/3. So that means x is equal to 1/3 to the 1/4. Okay. And this is an even root. I introduced an even root. So don't forget to do plus or minus. Okay. Questions on that? All right, so the only possibilities for relative maxes and mins are going to happen at these points here. So I'm going to do the first derivative test. This function is defined everywhere, but what? Where's the one place this function is not defined?
When x equals 0.
And x is equal to 0, perfect. So when I make my table, minus infinity to minus 1/3 to the 1/4, you should include 0 in it. 0, even though 0 is not a critical number, you could still have, because the function's undefined there, you could still have a change in the behavior of f, okay? All right. All right, so f prime is equal to 3x to the 4th minus 1, 3x to the 4th minus 1, divided by x squared. Okay, so let's look at some of these values. Okay, so it's hard to know how big 1/3 to the 1/4 is, but we know it's got to be bigger than, or smaller than rather, 1. It can't be bigger than 1. So I'm going to choose as a test value here, x is equal to -1. Okay. So what sign does 3x to the 4th minus 1 have when x is -1?
Positive.
Positive, very good. Positive. X squared, well, that's going to be positive all the way across. So f prime, I'm going to quickly fill this out. F prime is positive. Okay, between 0 and minus 1/3 to the positive 1/4. Well, that's also a little hard to decide what test value you should pick. So you should pick x is equal to, well, you could always pick halfway between 0 and minus 1/3 to the 1/4. So you could pick minus 1/2 times that. I don't have a lot of room to write that. X is equal to minus 1/2 times 1/3 to the 1/4. Okay, and when you pick that, you're going to get a negative here, and you're going to get f prime is decreasing there. Okay. I'm going to pick x is positive 1/2 times 1/3 to the 1/4 here, and you'll get that f of prime of x, well, we're going to get a negative here, and so a negative here, and then lastly, you should pick x equals 1 here to get positive, positive. So f prime is positive, negative, negative, positive, which means f is going from increasing to decreasing, and then from decreasing to increasing. Okay. Any questions? How would you write root 4 in a calculator? Just do exactly what I have. Just do stuff, and then to the, you would do caret, and then parentheses, you could do 0.25, like that. Okay, so f has, for right now, I'm just going to say f has relative maximum at x equals minus 1/3 to the 1/4, and f has a relative minimum. F has relative minimum at x equals positive 1/3 to the 1/4. Okay, so sorry I went a little over. I will fill out this last problem so you guys can see it before I upload the notes. But you have everything you need now to do more than half of the homework. Okay, so that's the first derivative test. It really is just this interval of increasing and decreasing, and you draw what f is doing beneath the graph. Okay. So any questions? If not, feel free to sign off. Thank you all for being here, and make sure to remember that I have office hours tomorrow 1 to 3. Okay.